Hi everyone, I just wanted to take the opportunity to make a tiny little screencast demonstrating the Mutant tool, which is a mutation tester for Ruby. Um, this is a spur of the moment thing. I did not prepare or practice this in any length, but it should be short and sweet, and I'm using Mutant actively on a project of mine, Yex. So we're going to look at some of the failing, or some of the live mutants, I should say, that are left in Yex, and in the meanwhile, you'll kind of see my workflow for using Mutant. Um, okay, so here's the full invocation for Mutant, but before we get to that, I'll quickly show. So I have, well, normally, depending on if you're doing a library or an app, you would have Mutant in your gem file or in your gem spec. So I have Mutant and Mutant RSpec in my gem spec. Mutant currently only has a runner that uses RSpec, but it should be pretty easy to add support for other testing frameworks. And so I have my project here. I have my RSpec suite. It's green, as you can see, but the question is, how good are these tests really? And so to do that, I'm gonna invoke Mutant, so bundle exec, so it gets the right version of Mutant and RSpec and everything. Include the lib directory, because that's where the code under test lives. Require Yex. These are necessary so Mutant can find the code that it works on, because it works all kind of magic on the syntax tree of your code. And then use RSpec, so already potential future support for other frameworks, that the reason that you already need to add this. And then you add what Mutant calls the subject. So in this case, I'm going to test the format class instance method of the Yex config class. Okay, so let's do that, and then you'll see a bunch of stuff happening. So I'm going to scroll up here a bit. So okay, Mutant just starts this stuff. Yeah, what it's testing and which strategy it's using. But so here it gets interesting. So you might think this looks kind of familiar, right? The green dots are tests that are green or are failing. But actually this is something different. So every dot is a complete run of all the 225 tests that you saw running above, or a subset thereof. And what Mutant does is it takes this format class method, and it makes little changes to it, and then reruns all your tests. And if the change causes a test to fail, then that's good, because then that's a mutation that is covered by your tests. If Mutant can make changes and none of your tests fail, then that's when you get a red F. So in this case, for this particular method, Mutant found 92 ways to mutate the method, and 89 of those were fine, but so there are 3 mutations left that are problematic. So if we scroll down here, you'll see these should be familiar to anyone who's done programming for any length of time, this unified diff format showing the actual changes that Mutant has made. And so here you see where this is supposed to be a rec environment, and we're testing if it has the key HTTP accept. But even if we take this call off, then no tests fail. So this probably means that we're only testing with environment hashes that actually have this key, but that we never actually test for the case where we pass in an environment variable, an environment hash which does not have this key. Similarly, so this is I guess this here Mutant just replaces the call with its argument, just to see if it's not just a call that returns itself or something. But this is basically the same case of what we see here. So we're only testing the case where this is always true. And so you see, out of 92 mutations, 89 got killed. So this is kind of the mutant terminology. You have mutations. If they cause the test to fail, they're killed. If no test fails, if your tests don't catch them, they're considered alive. Now let's go to our code. So this is the code under test, and then here we have the test file. Now you see that I follow certain naming conventions in this test file. So this is pretty standard, describe and then the class you're testing. But also when I test specific methods, then I use this Ruby syntax of a hash for an instance method or a dot for a class method. And I'll explain later why that's important. Okay, so here we have our format class test, and let's say that, so what should exactly happen? It should fall back to the default when no HTTP accept key is present. So, and I'm just gonna copy this here, a bit lazy for the case of this, and yeah, let's just inline that. So we pass in an empty rec environment, and the default that we've chosen is collection JSON. So is that oh, we have a problem on line 114. Yes, a bit too fast there. We still have a problem. No, that was actually correct. We pass it an empty hash and an oh, okay, typo from my end. Okay, so that's good. So our specs are still green, and if we rerun Mutant on this subject, we still have 3 failing mutations, or 3 live mutations. So I guess we should, let me see, okay, so it falls back, rest for a second, I haven't looked at this code for a little while. Yeah, so no. Okay, so we pass it a hash without this key. In case of this mutated code, it'll still get into this block, and I guess it'll create a car set of nil here, which I suppose is valid. So if that doesn't cause a problem, then yeah, then the test is not gonna fail, because it's just gonna fall through the block. What's the thing called? Rec accept. Okay, so rec accept is a bit lenient there. Now this is interesting, because this is basically a case that we can't really write a test for, which basically also means that this is redundant. So in other words, if rec accept, if we don't pass it an accept header, then rec accept is not gonna find a MIME type, and so it'll go past this line and it'll get here. And so I think that this should actually still cause no test to fail. And if we run Mutant again, there, that looks better. So this is actually super interesting, because this is the kind of stuff, like Mutant helps you find different kind of things, and this is one example. This was actually redundant code, and through Mutant I've discovered that I can safely remove it and make my code base a bit simpler. Similarly, sometimes you find code that is simply unreachable, and so yeah, that's I think is a super interesting example. Now the other thing I want to say a few words about, so you see here, so it has a matcher, which is going to look for tests based on a certain identification. And to demonstrate, okay, first of all, I have a rake task which does exactly the same as this, just so I don't have to type all that stuff, and it optionally takes pattern, which is the pattern that is going to be used to search for subjects. Now if I try to mutate the call method of mapper, then you see here a long list of classes and methods. So why is that? If we go and look at the mapper class, and I'm just naming the mapper tests. So I did follow the naming convention here of starting my test with describe and then the class, but I don't have a describe call block. So if I would have had this describe call block, then Mutant assumes that any change it makes to the call method should be killed by a method within these, should be killed by a test within this block. And you'll see that if I now run this again with this empty, yeah, see, so now suddenly all my mutations are left alive, because I don't have a single test here that tests anything useful about my call method. So whatever mutation Mutant makes to that method stays alive. And so this, you'll notice after a while of using Mutant that you kind of start automatically organizing your tests in this way, which some people will like, and for some people it might be a bit against what they're used to. But it's important for two reasons. First of all, it's definitely not a bad habit. Like testing a whole class, or sort of having your tests at the scope of a complete class, makes it very easy to miss things, whereas if you, at least for the methods that form the public interface of your class, it's definitely a good thing to have those specific tests. But the other reason, important reason, is that, as you might have gathered, so my total test suite here is relatively fast, 300 milliseconds, and so running that over and over again is not too bad, but still it's a third of a second. So if I would run Mutant on my complete code base, at the moment I think it gets about 4,000 mutations, and so multiply that by a third of a second, and suddenly you're talking about already quite a bit longer time, talking about 20 minutes. And so to be able to optimize that somewhat, Mutant tries to limit the amount of tests it need to run. So because you might be like in those 200 tests, they're testing all kinds of different parts of the code base, and when it's testing a specific method, when it's mutating a specific method, it's interesting to know that okay, these are actually the tests that concern this method, and these tests are supposed to kill any mutation in there. So it kind of works. It's a good habit anyway, but when you do it that way, you also help Mutant to do things in an efficient way. Um, so with that, I think I've touched on the most important stuff of using Mutant in day-to-day life. So I definitely hope you try it out. I'm super happy with the work Marcus is doing on this. It's hard. It's really hard to get a tool like Mutant right. It's complex. There's a lot of edge cases to consider, and I think Marcus is really pushing the envelope and doing a great job. And I think this is the thing that really could improve your projects and your Ruby code. So do try it out. Do report issues you find on the issue tracker on GitHub. And yeah, happy coding.